students, in this video I will discuss about integration by partial fraction. Now partial fraction method of integration we apply when we have a function of the type of px upon qx. Px upon qx means we have a rational function. Px upon qx, qx is not equal to 0 and both px and qx are in terms of x. Now when px upon qx is proper rational number, proper means when power of px is less than that of qx, we call it a proper rational function, and when power of px is greater than that of qx, we call it improper. So rational function should be proper. If it is improper, we will make it proper by dividing px by qx. So then what we do, when power of px is greater than that of qx, then this px upon qx can be written as, we will divide it, and we write it of the form of q r upon d, that is quotient remainder upon divisor, qr upon d. So let it be tx plus remainder, let us take remainder rx, divisor will remain same, that is qx. So it is of the form of quotient plus remainder upon a divisor. Now this rx upon qx has become a proper fraction. After this we have 5 different forms of this partial fraction. 5 forms of rational number are, and the 5 forms of partial fraction I have written in front of these. So first form is when we have a numerator linear polynomial and denominator is quadratic polynomial. That is of the form of px plus q upon x minus a, x minus b, where a is not equal to b. Then the partial fraction form will be a upon x minus a plus b upon x minus b. Then we will find out the values of a and b by equating the coefficients, and then we will integrate it. Second form is px plus q upon x minus a whole square. Difference between this denominator and this denominator is this: here we have a repeated root and here these are different factors. So px plus q upon x minus a whole square, then the partial fraction form will be a upon x minus a plus b upon x minus a whole square. Third form is px square plus qx plus r upon x minus a into x minus b into x minus c. Then the partial fraction form will be a upon x minus a, b upon x minus b plus c upon x minus c. Fourth form is px square plus qx plus r upon x minus a whole square into x minus b. Here x minus a is repeating twice, x minus a into x minus a. Then it will be of the form of a upon x minus a plus b upon x minus a whole square plus c upon x minus b. And the fifth form is px square plus qx plus r upon x minus a into x square plus bx plus c. This form, in this case, this quadratic equation cannot be factorized. Then the partial fraction form will be a upon x minus a plus bx plus c upon x square plus bx plus c. So these are the 5 different forms of a partial fraction. Let us do questions of exercise 7.5. Question number 1. Question number 1 is integrate x dx upon x plus 1 into x plus 2. Now you will compare it with the form. What we will do, let x upon x plus 1 into x plus 2 is equal to a upon x plus 1 plus b upon x plus 2. Now what we will do, we will cross multiply. So x will become equal to, when we will multiply this first term by x plus 1 into x plus 2, then x plus 1 will cancel, so x plus 2 will left. So it will be a into x plus 2 plus With this, when you will multiply, so x plus 2 and x plus 2 will cancel, and we will get b into x plus 1. Now, easy way to find the values of a and b is you put the value of x. First you put it equal to 0. When you will put it equal to 0, x will become minus 2. And when x will be minus 2, then this whole will become 0, because minus 2 plus 2 will make it 0, and we will get the value of b. And when we will put value of x minus 1, then this whole will become 0, and we will get the value of a. The other way is by comparing the coefficient. Now put x is equal to minus 2. When you will put here minus 2, it will be 0. X is minus 2. So minus 2 is equal to, x is minus 2 plus 1 is minus 1. So minus b. This implies this minus and minus will cancel, and b is coming out to be 2. Now we will put x is equal to, put it equal to 0. So x will be minus 1. So when you will put x minus 1, so it will be equal to, this whole will become 0, minus 1 plus 1 is 0, and x is minus 1, minus 1 plus 2 is 1, that is equal to a. This implies a is equal to minus 1. Now what we will do, these values of a and b, we will put it here. It means this x upon x plus 1 into x plus 2 will be equal to minus 1 upon x plus 1 plus b is 2 upon x plus 2. Now what we will do, in place of this function we will substitute this here. Therefore I will become equal to minus 1 upon x plus 1 plus 2 upon x plus 2 whole dx. Now we will separate these two functions. This can be written as minus 1 dx upon x plus 1 plus, let us take this 2 outside, dx upon x plus 2, take this minus sign outside, and it is 1 upon x plus 1. Derivative of x plus 1 is 1, which is there in the numerator. So it will become log mod x plus 1, and then we have plus 2. Its integration, derivative of x plus 2 is again 1, which is there in the numerator. So its integration will also become log mod x plus 2 plus constant of integration. Either you leave it here, or we can write it minus log mod x plus 1 plus, here let us use the property of log, n log x will be log x raised to power n. It means it will become log mod x plus 2 square. N is this, so log x raised to power n is n log x plus c, constant of integration. Now log a minus log b is log a upon b, which can be written as log mod x plus 2 square, log a upon b is x plus 1 mod plus c, constant of integration. So it is the integration of this function.